Hi, I'm Jay from Real Street Performance. Today we're out in Colorado at Peterson Fluid Systems to discuss dry sump oil systems. I'm here with Justin. He's a team member here at Peterson, and he's going to give us a bit of an education on why a dry sump system is better than a wet sump system and some of the things that you may incur as you transition into a dry sump system.
I'm Justin with Peterson. We're been in business since 1977. We're a fully American-owned company, and all of our products are made in-house from start to finish. From raw material to finished product to the consumer is all done by us and in the United States. We specialize in dry sump oil systems, doing pumps, tanks, filters, ball valves, everything that you need to put a dry sump system together for your car.
So I've got a little bit of experience with dry sump oil systems, but I've known for quite some time that they're kind of the best end solution for the oiling in your engine. Any expensive engine that leaves Ferrari, Lamborghini, Audi, Mercedes-Benz, they're dry sump oil systems from the factory for a reason, because it's superior engine protection. We've got some race cars out there with dry sump systems also. You know, as the engine makes more and more horsepower, there needs to be more oil available, quality oil available, to protect those metal components from touching down and ruining the engine. And a dry sump oil system is a critical component in the safety of your engine. So Justin, what is the difference between a dry sump oil system and a wet sump oil system?
So a dry sump oil system is the oil is stored outside the engine.
Okay.
So it's going to have its own oil tank, so we can tailor capacity. It's going to have an external pump instead of a pump that's internal into the engine. And it's going to allow you to really tailor what you want the oil system to do for the type of racing that you're doing.
Okay. What are some of the benefits that you get out of a dry sump oil system?
One of the big things is we can tailor the capacity of the oil system to what you need. We have externally adjustable pressure. We can run less oil or more oil depending on what that type of race application is to better suit the needs of that racing, which can reduce oil temps. It can keep the life of the engine better, and we can control volume and pressure a lot better in an engine with a dry sump oil system.
And for most of us that are out there in the community, we have an engine that is now making more power than factory. And some of these engines that started off with 4 or 5 quarts of oil, there is not a lot of oil available. And as the engine speed increases and the crankcase pressure increases from boost, and you start running that engine harder and harder, you have less quality oil available. So storing your oil off-site out of the engine helps give the oil an opportunity to calm down before it returns back to the pump, kind of an exit of the storm that's going on inside of the engine. So that's a critical component. And as you get into the mitigation of crankcase pressure, dry sump systems are a superior path. So most of us that are happy that we've now added a catch can, and that catch can is not spitting oil out of the engine, we think that we have a good control system of the crankcase pressure. However, there's a lot of power to be had in a dry sump system. Justin, what is a regular amount of horsepower that's picked up as you move from a wet sump to a dry sump on a common engine?
When we're looking at creating crankcase vacuum in an engine, a common number that you can pick up if you're pulling 12 to 15 inches of vacuum in that crankcase is 25 to 30 horsepower.
So not only are you improving the quality of the oil that's protecting the metal components, but you have an opportunity to free up horsepower with no additional stress to the engine. Actually operating the engine under less stress, but it's also making more power. So when shopping for a dry sump oil pump, I've seen that most manufacturers offer different stages of pumps. Can you explain to the end users what the stages of pumps are and what's the right amount of stages and whether or not they may be driving a fuel pump off the back of the pump? Like, can you run us through that?
Yeah, so a stage when it comes to dry sump is when you're talking about like a 4-stage pump or a 5-stage pump, that's the total number of pressure and scavenge sections.
Okay.
Typically a dry sump pump will have 1 pressure section and then the rest scavenge. So a 5-stage pump would have 1 pressure, 4 scavenge. And the more scavenge sections you have, the better oil control you can get in the engine, and the more places you can scavenge from. Now, you can also go overboard with it. So not every engine's going to need a 6-stage pump to properly scavenge the oil. On a smaller 2-liter Honda K-Series or something like that, a 3-stage can work really well in that type of application, where that might not be the case in something with an inline 6 like a 2JZ.
The opportunity to drive a cable or mechanical fuel pump off the back of the pump, that's another additional benefit here, because as you get to the point moving further and further up in horsepower, most electric fuel pumps become obsolete. You need to move to a mechanical pump, and driving that mechanical pump off of a cog belt is another accessory system that you must add to the engine. So being able to drive a fuel pump off the back of your dry sump pump is another benefit.
Or a vacuum pump or power steering pump if you choose to go that route. It's with an externally adjustable pressure, you can really dial in what you're going to need, because what you want an oil pump to do is create the pressure that you need, and anything over that, you're taking horsepower away from the engine.
Okay.
So we want to try and shoot for the proper amount of pressure at the proper amount of time with the proper volume to get your engine fed correctly and keep those bearings alive and keep your engine running the way it's supposed to.
Yep. So if you're working with an engine that maybe it makes 100 psi of oil pressure, that's fine. But if the engine will live the same life at 70 pounds of oil pressure, you're picking up free horsepower. Another thing with the off-site storage of the oil tank is it gives you an opportunity to warm the oil. So if you're using a lot of oil and you have an aluminum engine, you have aluminum rods, and you're drag racing where that oil is not going to come up to temp naturally, you can use either a wraparound heater or a heater element that's in the tank and warm the oil to operational temperature. Then you can prime that system to run the oil through the engine and give that all those components a chance to have some hot oil access, and they'll start to change some of those clearances, making it safer for startup. Another thing is if you're using an alcohol-based fuel and you have a dry sump system with a heater, you can cook your oil. You'll see racers in pits that have the oil tanks plugged in and the heater's running even though they're not racing, and what they're doing is they're heating that oil up and cooking some of that alcohol-based fuel that makes it into the oil, because alcohol contamination is a big obstacle and a detriment to the oil. And having a dry sump system with, again, that off-site reservoir gives you an opportunity to cook that alcohol back out, keeping your oil in the condition you need to protect all the metal components. Crankcase pressure is something that a lot of people just really don't wrap their head around. So can you give us a good illustration, an explanation of what the scavenging sections of the pump are actually doing?
So scavenging sections of the pump are pulling oil and air out of that engine. If you think about it, if you took all the wind resistance away from you when you're running, you'd be able to go a lot faster than something like that. And that's exactly what we're doing with the crank in your engine when we're pulling scavenge and pulling that air out of it. We make all the rotating assembly in that engine easier to turn, which frees up horsepower. And the other added thing is we're controlling how much oil is flying around, so you're not having these droplets of oil that are everywhere in an engine and they're getting hit by your rotating assembly, which slows them down. It doesn't seem like it would be a lot, but every little bit counts in racing.
Yep, for sure. And another thing is, like, if you watch, a lot of people, they'll balance pistons or they'll balance their connecting rods, and they're proud. They've gotten to zeros. Everything weighs the same. Well, when you take into account of the oil mass that's flying around in a crankcase and how much oil is on those parts, effectively changing the weight of the components, having good control of the windage and getting the oil away from all those moving parts on the non-friction surfaces, again, offers more performance. So we have two different oil tanks on the table here. Can you run us through the two very different options?
So there's a ton of options when it comes to dry sump oil tanks and what you want to do. And the main thing when we're looking at and talking with racers is what type of racing are you doing? We want to have the right amount of oil because we want that oil to get to the proper temperature to where that engine's going to be happiest without overloading it. But you also want to keep enough to where we can get the air out of the oil as well. Something like a drag race engine might use a 2-gallon tank, and an engine, and that drag race engine might be 2,000 horsepower and massive cubic inches, and we'll have a dirt late model or a road course car that uses a 4-gallon tank that's a 2-liter, and the style of racing is just so drastically different. We want to tailor the amount of oil that we're carrying to make that engine live the longest and treat that oil the way it's supposed to be. When it comes to tank heating and getting that oil to proper temp, we have a 6-inch tank laying right there, which is great for a wraparound heater. And then we can weld in a bung to use our in-tank heater as well. The other option we would have is a 1/2-inch weld-in bung like our dirt late model tank here. And you can just plug that in. It's got a 1/2-inch MPT. You run it, set it up, it'll preheat your oil really well. And when it comes to baffling systems, it's way different from, I shouldn't say way different, it's partially different when you're talking about drag racing and you're talking about circle track or road course racing, where those tanks are experiencing different types of G-forces, or even off-road. So with a tank like this, we have our spiral baffle system, and it goes into a filter. It's kind of bolt on, it's go. You don't need anything else with this tank. And you can set it up to run circle track, you can set it up to run road course. This tank would be absolute overkill on a drag race car. You'd be carrying excess weight, excess oil that you wouldn't need, and it's just going to end up slowing you down. As opposed to our 6-inch tank here, which is our lightweight version, which holds 2 gallons of oil typically in the system, and you can heat that up quickly. You're not running as much weight as you have to. You're not carrying that oil weight around. That's unneeded.
As far as the dry sump system as a whole, there are a lot of components because you're dealing with a pump, a mounting bracket, a drive system, a tank, and then all of your fittings to tie all that together. In the realm of fittings and line, what advice can you give to keep people out of trouble on plumbing their dry sump systems? What are the mistakes that most people that don't understand it but are putting on their first dry sump system, what kind of mistakes do they make?
A lot of times what we see is people using line that's not rated for vacuum. So anything on the suction side of the pump needs to be rated for 28 inches of vacuum. That's anything that's going into the scavenge sections, anything going into your pressure section. If it's not meeting that, you can actually collapse the hose and starve your engine of oil, creating massive amounts of problems. The other thing that we see is people want to try and use lines that are too small. So a lot of people look at the oil pressure that they get and everything like that because they think that's where all the work's happening in the pump. But if you can't supply the oil to that pump, you're never going to get the pressure out of it.
Right.
So they both play a vital role in keeping your engine alive. So using the proper size lines and the proper style of line is really what's going to help you out.
And this is critically important. You know, if you go back to, say, 20 years ago when I started working on cars, there were only a few manufacturers of hose and fittings. Now we've got a lot of stuff coming in from offshore. It's not all bad, but when you go to plumb your dry sump system, you want to be using a known quality set of fittings and line because you do have the opportunity now for a lot more leaks. If you're using a off-brand fitting, a poor quality fitting, you can really make a mess because if those lines get sucked closed, all of this is for none. You're gonna have a wasted engine because it can't flow the oil. So quality line and a name brand fitting that you know that when you tighten all this stuff up, you're gonna have a leak-free operation. So you'd mentioned windage, and you have to kind of close your eyes and imagine that. You've got a lot of parts spinning round and round and round at a high rate of speed, and a lot of fluid that's making its way down out of the engine, trying to return back to the base of the pan. When you talk about windage control and oil pan configuration, what are the benefits that a dry sump system offers in just the oil pan configuration itself?
Well, with the dry sump oil system, you can run a much shallower pan than you can in a traditional wet sump.
Okay.
This allows the engine to be mounted lower into the chassis, creating a lower center of gravity.
Yep.
It can improve handling, improve weight transfer, all of that, which is going to be beneficial to a race car.
So typically with a drag race only car, you're looking to have the crankshaft center line a certain distance from the ground, because the higher that crankshaft is up off the ground, the more prone the vehicle will be to wheelie. Well, this doesn't seem like a big factor, but once you get into a finely tuned race car, some guys are actually moving the engine up and down in the vehicle as a suspension tuning option because you're moving the weight in the vehicle. So not only do you have the opportunity to really control that windage, you have the opportunity to make a better tuned suspension based off of moving weight in the chassis. So when you do go to a dry sump system, you're going to lose that wet sump oil pan and your oil dipstick. what's the correct way to check the oil in a dry sump system to know that you've got it in a place where there's enough room in the tank for the tank to have optimized performance?
So with a dry sump oil tank, the capacities can vary from application to application, and even over the life of the vehicle as that engine wears in. We make dipsticks for our tanks that are purchased separately to check that level, but what we always recommend is half to 2/3 full with the engine running at 3,000 RPM.
Okay.
We want to see all those areas where that oil could be filled in that car. So even if it says a 2-gallon tank, you might have a 2-quart filter, and you might have a massive oil cooler that you're using for road course racing, or because you drive it on the street. You might actually put 2.5 gallons into that system.
Okay.
And somebody who's a drag race only with a solid block, no oil cooler, they run a 1-quart filter, they might run 1.5 gallons in that 2-gallon tank.
Okay.
It kind of varies. What we recommend doing is half to 2/3 full and as close to 2/3 as possible without blowing oil out your vent.
Okay.
So that allows to have everything functioning right, and it's even possible over the life of that engine. You might lower your oil by 1/4 from when you initially built it to when, as that engine ages.
Yeah, and you have, again, the opportunity to see the running oil level of the engine, because in a wet sump system, you turn the engine off, you check the oil, there's that much oil in the pan. But when you have a running engine where you're getting the oil pumped up to the top of the engine and it's trying to drain back down into the oil pan, but there's crankcase pressure trying to leave the valve cover, there's some traffic inside the engine, and some oil can be trapped up inside the top of the engine, which drastically affects the running oil level of the engine and can effectively starve that wet sump oil system. So in the dry sump oil system, you're checking the oil level at speed in operation, where you know that you can have this much oil available to that pump, protecting all those components. So most engine oil pumps in a wet sump configuration are driven off of a gear, or actually on the nose of the crankshaft, where the oil pump speed is the engine speed. Given you can change the pulley configuration on one of these dry sump pumps, what does that give you as far as opportunity in controlling pump speed, and what does optimum pump speed look like?
So optimum pump speed for us in our R4 pump is 4,500 to 4,800 RPM. And we want to do that to minimize cavitation risk. We want to do that to maximize the efficiency of the pump and allow that scavenge section to work right. Yeah, like you said with the OE engine, those engineers that designed that engine set that pump speed at a certain rate. And when we're talking about racing engines and doing other things, you're talking about raising the RPM level of what that engine was capable of, and having to fine tune what the pump is capable of to what that engine is.
So let's say you've got a customer, now we've got their attention. They're taking their racing program seriously. They understand that there's expense involved to moving to a dry sump system, but they realize that after they've had 3 or 4 engine failures and their oil related failures, and they're looking to save money in the long run, they're ready to pony up and start to piece together a dry sump kit. Where do they start? What are their questions? Do you guys offer a base information for them to move forward with?
So on our website, we have a pretty robust FAQ section that goes over a lot of pump selection stuff, history of dry sump, how we can configure a system. But one of the main things we're really concerned with is what that engine block is made out of, what the rods are made out of, rod main bearing clearances that you would have in the engine, and your goal for the system is vitally important for how we're going to tailor our pump to meet the needs that you have for your race car.
So if we piqued your interest and you want to learn more about dry sump oil systems, feel free to reach out to Real Street or Peterson, and we can get you on a right path to have an optimized oil system. You're looking to make more power, have safer operation, and better control of oil temps through a dry sump oil system. Not to mention, if you're revving that engine higher, you can have a optimized pump speed instead of overspeeding the oil pump. I know it's a lot of information, but these are good things to add to your vehicle, and again, it's why all those high-end, expensive OEM engines are protected with dry sump oil systems. Thanks for watching the video, and we'll see you next time.